Okay, so continuing on with page 25 here, we're going to be looking at simplifying by clearing parentheses and combining like terms. So clearing parentheses means we're going to be using that distributive property unless you are, 100% of the time getting all of your negatives correct, then I do recommend going through and writing down that each of these subtractions is really adding the opposite. So you remember that the negative goes with the thing after the subtraction symbol. So for example, in this top left one, I'm going to change that to adding a -4. And now when I go through and multiply by 7 to clear the parentheses, I won't forget that it's really a -4 there. So I'll have 7a plus a -28, and then the 8 from above that I will just drop down. And then get any like terms together. So 7a, there are no other a terms, so that'll stay put. And then -28 plus 8, so plus -20. And that is fine. Otherwise, Alex will prefer this one, but if if it's a test or a quiz, you can do either one. I am fine with either. I know that they mean the same thing. Alex doesn't always remember that. And in the next one, we've got a couple negatives, subtractions here that I'm going to change into adding the opposite. So change that to adding a -5, and then change that to adding a -5m. So that I can multiply that -5 through the parentheses. So the 10 out front will stay the same. Then I'll have plus a -10 when I do -5 times 2, and plus a positive 25m when I multiply -5 by -5m. And then the 10 and -10 will add to 0, leaving us with just 25m once we've simplified that. So simplifying these things is going to help us as far as solving equations when this might be one side of an equation that we need to get down to a simpler form so that we can continue our process of solving the equation and getting everything balanced and all that. So let's do, let's see here. Let's do this one. And then these last couple, I think I'm going to leave for you guys to do at a later time, and then I will make PDFs of the notes completely filled out so you can check and see against my work and answers later. I'm going to go through and change these to adding the opposite. There we go. And for each half of this, I do need to deal with the distributing and then go through, so I can do those at the same time since they're separated by addition, but I'll do the 6 times each thing here. So 6y plus -54, and then the -5 will multiply by each one, so we'll get -10y plus -5 times -5, which would be positive 25. So we will have -4y, and then plus -54 plus 25, because they're right, the y's I can add together. And then these two, I need to do that subtraction of the absolute values off to the side here. Whoops. So, okay, so I'm going to get 29. And because the -54 has a larger absolute value, it'll be a -29. So either that can be your answer, or -4y minus 29 will be your answer. And yeah, Alex does not like the adding the opposite idea, but sometimes we need to think about it that way to make sure that we're not missing any of the moving pieces. So Alex would prefer you to put it in this way if it is on an Alex homework problem. All right, I'm going to pause here and flip to the next page, so we'll be on to page 26. So continuing on page 26, we are looking at moving on to the solving, and a little review on solving equations. So the solution of an equation is the number that gives a true statement when substituted for a variable. And a true statement is something that is true, which is something like 2 equals 2, right? We can't argue that. 2 is itself. So if you get that, or if you get like -5 equals -5, those are examples of true statements. Now, if you get 2 equals 3, that is not a true statement, and that would tell us that something is not a solution for an equation. The next set of terms here, so looking at a solution set, is the group or set of all numbers that are solutions to the equation. Another way to say this is all the solutions that satisfy. So that is a verb that sometimes will be used with solutions. They satisfy the equation. Okay, so you can think the Rolling Stones, maybe. If equations share, so I just had to double check there. So equations share a solution set. They are called dependent equations. Essentially, they are the same equation with a costume change. So it's similar to when we were looking at adding and subtracting those fractions. So these properties of equality basically say that if I do the same thing to both sides of the equation, no matter which operation I use, it will keep the equation balanced and it will still mean the same thing. So if A equals B, then I can add C to both sides and it still will be equal. I can subtract C from both sides. I can multiply C on both sides of the equation, or I could divide both sides of the equation by C. But no matter what, I'm doing the same thing on both sides to keep the equation balanced. So that's the big thing here. So whatever you do one side of an equation, you've got to do the other. Otherwise, you've changed the equation. And solving it isn't going to mean anything because it's not the same equation anymore. All right, we are going to flip pages here. I'll pause for one moment. So here we are on the top of page 27. So we are solving equations, and our goal is to get the variable by itself on one side of the equals sign. We're going to keep the equation balanced. So using all those properties we were just talking about on the previous page. What you do one side of the equation must be done to the other. Must. And we undo what has been done to the variable by using inverse operations. So addition will undo subtraction and vice versa. And multiplication will undo division and vice versa. So hopefully that makes sense. You know, if you divide something by 2, then if you multiply it by 2, you would get back to where you started. If you add 7 to something, then if you subtract 7 from that, you would get back to where you started. So that's what we're doing, is trying to undo all of the steps that we've taken to the variable by undoing those things. So most of the examples that we're going to be looking at for this portion is solving equations using those different properties. But the first couple, we are going to be checking to see if a given number is a solution for the equation. And this is something that, for some reason, in winter term, we were having a hard time with. So make sure that you understand these. These are going to show up on the test and the exam. So make sure that you are settled on this before we get to that. So when we're substituting in a value, you are going to write down the equation, except for parentheses around where that variable is. And then we're going to use the given number and see if it's a solution by plugging it in there for -1. Now, the other thing that I do when I am checking to see if a solution works, I don't know if it does or not. So I remind myself that I am checking by putting a little question mark over the equals sign. And then I go through and I see if both sides of the equation will be equal, if they'll be the same. So on the left here, we would get -5 plus 3, and I'm checking to see if that's going to be equal to -2. -5 plus 3 would be -2. Does that equal -2? Yes, it does. This is a true statement right here. So -1 is a solution. And the next one, I'm going to do the same thing, right? Leaving parentheses where the variable was. So I have something to plug in, a spot to plug my number into. And question mark over my equals sign, and then I'm going to check and see if I put 12 in there, am I going to get the same thing on both sides? So this would give me -12 plus 8, checking to see if that's going to equal 20. -12 plus 8 is actually going to be -4. So this is not true, right? -4 does not equal 20. This is not true. False statement. Which means that 12 is not a solution. So you might need to say whether or not the solution is, whether the possible solution is truly a solution. So whether that given number is a solution is going to be kind of a yes-no question, but this is the work that you need to decide whether or not it's true. All right, next couple, I'll do a couple of these. We're not going to do all of them, but I will post PDFs of all of these worked out so that you can look back at them later if you need to. All right, so using the addition or subtraction property of equality. And remember, we're also thinking about undoing. So here we have x minus 23. So we want to undo subtraction. And we're going to undo subtraction by adding 23 to each side of the equation. Remember, I'm keeping it balanced. You know, sometimes it helps for people to put a line there to separate the two sides of the equation. Over here on the left, then, I'm going to have just x, right? Because the 23 and -23 will become 0. X equals, and then I go ahead and add these and get 37. And there's nothing else that has been done to x, so that would be my final solution. X is 37. Oh, excuse me. So the next one I am going to look at on the right here. So if I have a -4 here, I am going to want to add a +4. And the reason we do that is then that becomes 0, so that I just get k by itself over here. So k is on the left side of the equation, and over on the right, we will have 16. And looking at the one right beneath there, to get the b by itself here, I'll want to subtract 17, because then these two will become 0, which is what we want, because we want to get b by itself. And then over here, 20 minus 7 will give us an answer of 3. All right. And I am going to stop the video here, and then I will move on in the next one.